many of you are worried about the coding preparation, that how we have to do it. So guys, in this one short video, I know this video will be very long, around 1 hour 40 minutes or 2 hours video it is, but guys, are 7 to 8 coding questions I have covered in this video. Every question is previously asked in Accenture, and the main aim of this video is to like tell you the different type of concepts, try to make you understand different types of concepts that are used in these questions. In this you will see the question related to dynamic programming, question related to greedy algorithm, question related to stacks, two pointer. So all these type of questions and concepts you will learn in this video. The questions are not more, just 7 to 8 questions I have covered, but each and every question is a medium level question which was previously asked in Accenture, and it will help you in understanding the concept. So if this similar type of question is asked in your exam, so that you can like get a fair bit of idea that how to solve these type of questions. So guys, don't skip any of the questions. I know the video is very long, you can watch the video in bits and bits part, okay, not all the things at one time, but make sure that every question that I have covered in this video, you should know that question, okay. Very important concepts are there, different type of concepts you will be getting to learn in this particular video. Okay, so guys, the question here is, given an array of size n, print the next greater element of every element. Okay, the next greater element for an element x is the first greater element on the right side of the x in the array. Element for which there is no greater element exists, consider the next greater element as -1. So guys, I know the question might not be clear to you, so let's just quickly move towards the example, and then the question will be clear to you. So we have an input array called 4, 5, 2 and 25. Now what we have to return an array of same size only in the output, but what should be the value? So for every value in the array, we have to print the next greater value in the array. For example, if we are at this 4, so what is the next greater element of this 4 in the array on the right side? Okay, we have to move towards this side. So if we are at the 4, then what is the next greater value starting from 4 towards the end, and that is greater than 4 and just greater than 4, okay, just after the 4 only. So it is 5, because when we are moving towards the right side, so the next greater element of 4 is 5. Similarly, when we are at 5, what is the next greater element of 5 when moving towards the right side? The next greater element of 5 moving towards the right side is 25, because 2 is less than 5, so no issues here. We have to find the next greater element. So the next greater element of 5 is 25. So we are printing 25 here. So now we are at 2. So what is the next greater element of 2 on the right side of the array? It is 25 only. Okay, when we are moving towards the right. Now when we are at 25, what is the next greater element of the array? Okay, so if we move towards the right now, for finding the next greater element, we'll move out of the array only. So for this 25, that is for the last element of the array, there will be no greater element that will be present. So here we are returning -1. Okay, so this is the output. Okay, so guys, see, there can be lot of variations for this next greater element. Okay, so there can be a circular rotation also. There is one variation where is a circular rotation is also possible. So in that case, we will not print -1. In that case, we will again for 25 we will start from the first letter, first element only, and then again iterate the array, that okay, which is the next greater element. But for this particular question, since for the last element there is no next dot element present, circular rotation is not here, so therefore we have printed -1. So while doing the question in the exam, same question comes, so don't assume that okay, -1, so you have seen in the video that for the last element there is -1, so you just go and print -1. No, you have to read the question very carefully. Next question, next example is, we have an array 5, 7, 1, 7, 6, 0. Again we have to output the array, and for every element we have to print the next greater element. So what for the next greater element for 5 is, the next greater is 7. Okay, the next greater element for 7 is, while moving towards the right side, so after 7 it is 1, after 1 it is 7, after 7 again it is 6, after 6 again it is 0. So next greater element for 7 does not exist. You will be saying, sir, 7 is the next greater element. No, it is not next greater, it is equivalent to it. You have to find the next greater element. So is there an element on the right side of 7 that is greater than 7? No. So therefore we are printing -1 here. Similar is the case with 1. What is the next greater element of 1? So when moving ahead, so it is 7 only. So the first next greater element is 7. When again we are at 7, so we all know that for 7 it is -1 only, so we have printed -1. Now we are at 6, so is there any next greater element after 6 that is greater than 6? So answer is no. So again -1, and since we are at the last element of the array, so the answer is -1 for this case also. So this is the output for it: 7 -1, 7 -1, -1, -1. So I hope now the question is clear to you. Now let's just quickly move towards the approach of this particular question. Okay, so as for this particular question, we will be following a stack based approach. Okay, so as I have told you that in every question you will be learning something new, data structure or some new algorithm. Okay, so total around 8 questions I am covering in this video. So for every question you will be learning a new set, okay, new data structure or the algorithm. So please hit that like button if you are finding this video informative till here. So in this case we will be using the stack based data structure. So this is a stack. I hope you all of you know what is a stack. It follows the LIFO approach, that is last in first out. So what we will do, as you all know, the output of this particular array will be -1, 25, 25 and 4. This will be the output of this array. We were like, while we were discussing the question, I have told you that we will be seeing towards the right of the array. Okay, we will be going towards the right of the array and we will be checking the next greater element. But for solving it, if you will go like this, if you will go start from this element and go towards the right of the array, then the approach that you will be using is a n square approach. Okay, that will not pass all the test cases. That will give you time limit exceeded error in the compiler of Accenture. The optimized approach for solving this question will be to use a stack based approach and to start finding the values from the last element. Start finding the value from the last element. Okay, so this is what we'll be doing. Okay, this particular approach will be big O of n approach and it will be passing the all test case that will be given to you. So having said that, so let's start this question and we will be traversing, we will be finding the next data element from the last element. So last element is 25. Okay, so this is the output array. See, this is the answer that we have to find, but this is the output array we will try to fill step by step. So we are at the last element. I have told you that whenever the last element is there, there is no possible answer. It will be always -1. The answer will be always -1. Okay, always -1. Now we were at this element and this was the last element. So we have just placed it, just given -1 in the output array, and what we have done for this 25, we will simply add this 25 into the stack. Okay, let me just make this stack a bit big. Okay, we will simply add this element in the stack. So 25 we have added. So the role of this 25 is done. Okay, -1 we have found in the output array, we have added this in the stack. Now the role of it is done. Now we are coming at 2. So the current element is 2. What we will do, we will first check the top of the stack. Okay, when we are at the current element, we will first check the at the top of the stack. Okay, first thing will be to check top of the stack. So if the element at the top of the stack, again I'm telling you, if the element at the top of the stack is greater than the current element, then the top of the stack will be the greater value, of 2. They will be the next greater value of 2. Again, let me tell you what I was saying. Let me write. If top value is greater than the current element's value, the current element is 2 and the top value of stack is 25. In this case, what we will do, in this case, the next greater element for current element, that is 2 in this case, will be top only, will be top of the stack only. Okay, will be top only. So the next greater element of 2 will be 25 only. Okay, this was the case if the top value is greater than the current value. So this we have done. Okay, this we have done. Now we are at 2 and we will simply put this 2 into this stack. Now the role of this 2 is done. Now we are moving towards the 5, that is the next value is 5. Now what we'll do, since the next value is 5, so we will again check that whether the top of the stack value is greater than 5. So current value is 5 and the top value of the stack is 2, so it is not greater. Okay, so it is not greater. So the third step will be, if it is not greater, okay, if it's not greater, what we will do then, if it's not greater, we will remove the top of the stack till the value becomes greater. We will start removing the value from the top till the value becomes greater. Okay, so current value was 5, top value was 2. We will start removing the element from the top of the stack till the value becomes greater. So 2 is smaller than 5, so we will remove it. So now the top of the stack becomes 25. Okay, so now the top of the stack value is greater than 5. So in this case, what we'll do? So it means that 25 is the next greater value of 5. We will put 5 inside this. We will put 5 inside the stack and we'll move ahead. Now the current value is 4. Now the current value is 4 and we'll check the top of the stack. So top of the stack value is 5. So top is greater than current value. So therefore the next greater element for 4 will be 5 only. Okay, and we'll put it in this 4 into this stack. Now we are at this position. So our entire traversal of this array is done and we have got our output array also, and you can see this is matching. So this was 525 minus 1. So this is also 525, 25 and minus 1. So this is matching. So I hope now this approach is clear to you, but let me just explain you with the another example also, so that it becomes robust, it becomes clear in your mind. Okay, so I will write down the steps in detail, and then I will be telling you the another with the help of another example. Okay, so let me just do that for you. Okay, so guys, I hope you are finding this video informative till now, and guys, do join our Telegram group if you have not done it till now, because it is a dedicated group for 2025 batch and regular Accenture discussions regarding any queries you have. We are having discussion here. So the link you will find in the I button or in the description box. Do join this Telegram group; it will be very beneficial for you. Now, moving towards the next example that I was telling you. So I have already written down the algorithm. Okay, so as you know, we will start traversing this array from the in reverse order. Okay, so first step was put last element inside the stack and start traversing array. Okay, so as I told you, for the last element, we will always put the last element in the array, in the stack, and we'll start traversing from behind. Okay, and for last element, the next data element will be always 0 in this particular question. Okay, so now we will traversing from the behind. So now currently we are at 6. Let's just read the second point. First point is done. Let's just read the second point. If the top element of the stack is greater than the current value, okay, current value is 6 and top is 0. If the top value of the stack is greater than the current value, then the top value will be the next greater value of current value. Okay, this is one point. So current value is 6, top value is 0. So is this if condition is satisfied? No. If the top value is greater than current value, then only this if condition will go. So top is 0 and current value is 6. So in this case, no, in this case, this if condition is not valid. So if this condition is not valid, we will move towards the else condition. So else condition is remove top element till top is greater than current value or stack is empty. So current value is 6. So what we'll do, we will start removing the top element. Okay, we will remove 0. Okay, we have removed 0. So now our stack has become empty. Okay, till when we have to remove elements? Till the top value it becomes greater than the current value or the stack is empty. So since we have removed 0 from here, so now the stack has become empty. If the stack has become empty, okay, if the stack has become empty, it means that there is no greater value that is present for the current value while moving towards the right. So in this case also minus 1. So for 6, there is no greater value, no next greater value exists. Okay, I hope this is clear to you. And once the roll of 6 is done, we will add 6 into this stack. Now coming to 7. So 7, so current value is 7, top value is 6. So again it is not possible. Okay, so first again this else condition will run. So remove the top of the elements till the top becomes greater than 7 or till the stack becomes empty. So we are removing 6. So once we have removed 6, so this element, so the stack is empty. Okay, so once stack becomes empty, so it means that there is no next greater element for 7 that is present. Okay, so again it's minus 1. Next, this we will put 7 inside this one. Next is 1. So we will now run. So is top value greater than the current value? So top value is 7, current value is 1. So yes, it is greater. So if it is greater, then the next greater value of 1 will be the top value, that is 7. Okay, now we will add this 1 here only. Next, moving to this this one. So now the current value has become 7 and the top value is 1 and 7. So now we will start removing the elements till the top value till the current value becomes less than the top value or the stack becomes empty. So 1 is less than 7, so we will remove it. So 1 is removed. 7 is 7 less than 7 less than equal to 7, because we have to find next greater element. So 7 is equivalent to 7, we will remove it. Okay, we will remove 7 also. So once we have removed 7, so our stack has become empty. So for this 7, the next greater value will remain minus 1. And now we'll put this 7 inside the stack. Now coming to 5. So is the top value greater than current value? So yes, the top value is greater than the current value. So in this case, the top will be the next greater element of 5. So that is top is 7. So 7 minus 1, 7, triple minus 1. So if you will look closely, this is the resultant output: 7 minus 1, 7 minus triple 1. So I hope now this and that algorithm is clear to you. So now let's just quickly move towards the code. The things will become more clear there. Okay, so if you have not subscribed the channel till now, please subscribe it, and if you have found this video informative till here, do hit that like and subscribe button for this channel. Okay, so guys, for saving time, I have already written the code. I will be explaining you line by line that I have explained you in the approach also. So we will follow the approach only. So first of all, see, in Accenture, only the function you have to implement, not the entire input and output things, not those things. Okay. So what I have done, first of all, we have declared a new vector, because see here, I am writing the code in C++, but you can write in Java and Python also. So this is the input format that is given to you. That is, these are the input to the function, and this is the output. That is the resultant you have to return from the array. Okay. So vector int I have declared that will be returning from the array. If our this is the base case, if our n is 0, that is the size of the array is 0 only. So we have to do nothing, just simply return this answer array. Next comes the things. We have to define the stack here, and I have told you for the first element, always push that element to the stack. So this is the last element, sorry, for the last element we are directly pushing this element into the stack. Okay, and we are in our output array, we are placing the last value as -1. So answer n minus 1 equivalent to -1. This is our output array. Okay, why it was output array? Because for the last there will be no element that will be present to you. So this, for this, we are automatically doing -1 here. Okay, now let's just follow the algorithm. So we will just iterate over the array from behind. As I have told you, it will be iterated in the reverse manner. So starting with I is equivalent to n minus 2, I greater than equivalent to 0, I minus minus. So we will find first the current value. Current value is the current value. Yeah. Now we will check if the current value is less than the top of the stack. If the current value is less than the top of the stack, what we are doing? So the next greater element of the current value will be the top of the stack only. So our output array's current value will be the top of the stack only. This was the case when our current value is less than the top of the stack. Else is the case that if the current value is greater than the top of the stack. So in that case, I have told you, we will start popping out the elements from the top of the stack till if the if the array becomes empty, or the top of the stack becomes greater than the current value. Okay, so this is the condition in the else state. So we will be running a while loop till our stack is not empty, and till the s top value is less than equivalent to current value. We will keep on popping the elements. Okay, we will keep on popping the elements. Once this while loop is breaks, now we will check whether our array is empty, or whether it has it has the value greater than the current value. So by this line we will be checking it. That is, s dot size greater than 0. If it will return true, that means top element is present and top element is greater than the current value. Okay, s dot top. Otherwise, if the stack is empty, it means there is no greater element present from the current value. So therefore we have returned -1. So this we will be doing for the entire all the array elements, and in the end current element is pushed to the stack. Okay, so this you will do for the all the elements, and in the end from this particular function we are simply returning the our output array or vector, you can see. So let's just see with the help of the example input. Okay, so that it will pass all the test cases I have already checked, but for your sake I am checking again. So yeah, so 4 elements are there. These are the elements, and what it should return you 5, 25, 25 minus 1. Okay, so 5, 25, 25 minus 1. So it will pass all the test cases that will be given to you. So I hope you found this question informative. Please do hit that like and subscribe button for this channel if you have not done it till now. Okay, now we will move towards the next question, and you will be learning a new algorithm or data structure in the next question. So make sure that you are watching that question also till the end. Okay, so guys, this was it. Thank you for this particular question. Now, okay, so guys, the next question is, given an array of random numbers, push all the zeros of a given array to the end of the array. All non-zero elements should come in front, and order of all non-zero elements should be same. Let's just see with the help of the example. So we have one input of random numbers 1, 2, 0, 4, 3, 0, 5, 0. Okay, now what we'll be doing, so all the non-zero elements should come in front and all the zeros should move behind. Okay, and the order of all the non-zero elements should remain same only. That is, the output should be first 1 is coming, then 2 is coming, then 4 is coming, then 3 is coming, then 5 is coming, and then all the zeros at the end of the array. So this should be the answer for it. Okay, so see, the order of all non-zero elements remain same and all the non-zero elements came in front, and the remaining zeros moved at the back. Similar is the case with the next output input. So 1 2 double 0 triple 0, sorry, 3 6. So first 1 should come, then 2, then 3, then 6, keeping all the positions of non-zero element same, and then 3 zeros at the back. So this is the output. Okay, this is the output. So I hope now the question is clear to you. It's on the easier side. So let's just quickly move towards the approach, and approach is also very simple for it. Okay. Okay, so guys, the approach is also simple for this particular question. What we'll do, we will take it is a two pointer. So through this particular question, we will be learning two pointer approach. Okay, two pointer approach we will be learning through this question. So what we'll be doing, we will be taking a variable called count. Okay, so initialize it with 0. This count variable will store that how many zeros are there in the array. Again, I'm telling you, this count element will store that how many zeros are there in the array. What we'll do, we'll take two pointers. One is this I pointer, another one is this j pointer. I pointer, if I tell you, I pointer will iterate the entire array, will iterate the entire array. Okay, what will j pointer do? J pointer will store will point to the position, will point to the position where next non-zero element should be present, where next non-zero element should be present. Do understand this point very carefully. So three things we have done: I, j, and count. Okay, I also will be initialized with 0. It will help in iterating the entire array. J will also be initialized with 0. Okay, okay, and what will j doing? J will point to the location where the next non-zero element should be present. So j will be initialized with 0 only. That is the first index only. So now I is using for iterating the array. So now at I we have 1. So at I we have a non-zero element. So once we encounter a non-zero element, it will be assigned to the j. Okay, I am writing this here. If ARR of I if ARR of I is not equivalent to 0, it means it is a non-zero element. Then in that case, what we will do, we will assign that to ARR of j equivalent to ARR of I, because j is storing the position where the next non-zero element pointed. So therefore ARR of j is equal to ARR of I. We will do, in this case, I plus plus we will do, j plus plus we will do. Okay, this is the case when ARR of I is not 0. Else if the ARR of I is 0, then what we'll do, in that case we will do, first of all, count increment we will do. Why count increment we will do? Because we will store the number of zeros that are present, and only this thing we will do. Now let's just see. Okay, let's just draw this line here so that j, you can see I and j. So I is non-zero element. So in this case, what we'll do, AR of j equal to AR of I. So AR of j is equal to AR of I, and in we have done it. It is already the same because it was the first element. We will do I plus plus and j plus plus. Okay, again AR of I is non-zero. So again we'll do AR of j equal to AR of I. Again this I will go here, j will go here. Same thing is happening. Now see what happens. This I, current AR of I is equivalent to 0. It means what we will be doing, we will be increasing the count of 0. So we will be increasing the count of 0. That will become 1. And now we will only do I plus plus. We will only do I plus plus. I have told you what j will store. So j will store the position where next non-zero element should be present. So now see. So current I is a non-zero element. This if condition will run. So it means AR of j is equivalent to AR of I plus plus j plus plus. So AR of j is currently here, and AR of j equivalent to AR of I. So this will become 4. Count has become 1. This will become 4. Okay, this will become 4, and we will do what we will do. We will do j plus plus. J plus plus. Now j will now come here. I will come here. So again, I is again the non-zero element. So what we'll do? This will become 3. This will become 3. Again we will do j plus plus. J will come here, I will come here. Now I is a non-zero element. Oh, I is a zero element here. So in this case we will increment the count to 2. So 1 will become 2. I increment will be done. J is still there only. Now again it has encountered a non-zero element. So therefore what we'll do, we will do error of j is equal to error of I. So this will become 5. this will become 5. Okay, then again we'll do I plus plus j plus plus. Okay, j is now pointing to this. Now what is done? So I is 0. So I is 0, so we will increment the count to from 2 to 3. 3 i's are present and j is at this position only. And after we have encountered 0, so I will go here. That is, you have traversed the entire array. So now see, you have traversed the entire array. All the non-zero elements are already present in the front of the array. 1, 2, 4, 3, 5, keeping their position preserved. Now see, where is j? So j is, again, I have told you, j is present there where the next non-zero element should be present. So j is currently pointing to here. So now all the non-zero elements we have covered, we have brought in front of it. Okay, j is pointing to this element. Okay, and I has gone out of the loop. Now what we'll do? What is the current scenario? 1, 2, 4, 3, 5. 1, 2, 4, 3, 5. What is the array? 0, 5, 0. 0, 5, 0. J is here. Count is 3. Count equal to 3. It means there are 3 zeros left, and we know that these 3 zeros will be coming at the back of the array only. So now from j till the last of the array, there are 3 elements and count is also 3. So till from j till the last of the array, we will we will make all the elements as 0. So j 0, then this also 0, then this also 0. So this will be a resultant, output. Okay, so I hope now the approach is clear to you. It is very simple. We have like preserved the order also. We have got all the non-zero elements in the front also. And once the j was here, so in the end count was 3. So from j till the end of the array, we have made all the elements as 0. So this is how we will be solving this question. I hope the approach is clear to you. Now let's just quickly move towards the coding part of this. But okay, so guys, for saving time, I've already written the code, as you all know. So what we have here, we have a function. Okay, we have given the input here with input array and length of the array, and we are returning an array only. Okay, so we are taking 3 variables, as I've told you. Int count equivalent to 0, I 0, and j 0. We all know why they are useful. So I was used to iterate over the array. So for this loop, we have used the I for iteration. Then at every step, at every element, we'll check whether the current element is not 0 or not. If the current element is a non-zero element, then what we'll do, we'll simply do v of j equivalent to v of I, and we'll do j plus plus. We are also doing it I plus plus, but here in this for loop, I is automatically getting incremented, okay, after every iteration, and that is what we wanted. Okay, so this was the case when we are having the non-zero element. But if the case where we were having the zero element, in that case what we are doing, we were simply incrementing the count. That is, now we are storing the number of zeros in the count variable. After this loop is over, all the non-zero elements with their respective positions were in the front of the array, and we in the count variable we have that how many zeros are there. So now the j was pointing to the next non-zero element where all the non-zero elements were finished, and it was pointing to the next position. So starting from that jth position till the last element of the array, we are running a loop and we are putting all those values as 0, and we are simply returning v from here. That is the our input array. Okay, so in Accenture there might be some different input and output cases. You will have to look on their own, but for explanation purpose, I'm just telling you that what does output and input looks like in my question. Let's just see with the help of the example. We have random numbers. Let's suppose 5 0 7 5 sorry 6 digits we have. So 5 space 0 space 7 space 0 space 0 space 5. So the answer should be 575000. Okay, it should be the answer 575000. Let's just wait and check. Till then, do hit that like and subscribe for this channel, and do join the Telegram group. The links are in the description box. So here you can see that our output is coming as 57500. Okay, so there is one base case that is also remaining. So one base case is also remaining, that is if our n is double equivalent to 0. So if our n is double equivalent to 0, simply return the incoming v only. Okay, incoming v only, simply return. So yeah, one test case we can take more from here. Okay, 1204350. Okay, let's just run it. Let's just quickly run it. How many elements were there? I think, yeah, 8 elements are there. Yeah, you can see all the elements are coming at the front of the array with their relative position same, and all the non-zero elements have moved ahead. Okay, so this was all for this question. I hope the entire question approach and the code is clear to you. If you are finding this video informative till here, do hit that like and subscribe. Let's discuss the question first. a list of integers, okay, nums, that is like there will be total of 10 to the power 5 integers, okay, representing an array of numbers. Return the maximum sum of any contiguous subarray in the given array. Okay, so first of all, what is a subarray? I have told you in previous videos also. So if it is an array of 1, 2, 3, 4, 5, so this is a subarray, this is the subarray, this is the subarray. But if you will pick 1 and 5 exclusively, then this is not a subarray. So subarray is the contiguous part of the array, contiguous part of the array. This is the subarray. Okay, so I hope now the subarray is clear to you. Now let's just look towards the code question that what it is saying. So it is saying that we need to find the maximum sum of any contiguous subarray, maximum sum of any contiguous subarray. So if you will look closely, you will find that in the input there are certain numbers which are negative also. So we, out of all the subarrays, we have to find the maximum sum subarray. Okay, so out of all the subarrays, we have to find maximum sum subarray. Okay, so let's just take an example here. So there is an array that is given to us. So -2, 1, -3, 4, -1, 2, 1, -5, and 4. So this is a array that is given to us. Now this array, I have told you, there can be multiple subarrays. Okay, there can be multiple subarrays, but we need to find the maximum sum subarray. Okay, and we have to return that sum. Okay, so here you can see the output is 6. So in the output 6, what will be the maximum sum subarray? So that will be where it has gone 6. Yeah, this one. Okay, this one is the maximum subarray. So 4 minus 1, 2 and 1. So what is 4 plus minus 1 plus 2 plus 1? This, that is giving us 6. So there are a lot of subarrays. Okay, there will be a lot of different sum of the subarrays, but we have to find that subarray which has the maximum sum. So if you will find all the subarrays and calculate the sum of each subarray, then also the 6 will be the highest one. Okay, 6 will be the highest one. So this is what we have to return. If you will see the next input, that is 3 minus 1, 2, 5 minus 6 and 3. Okay, so in this case, if you will look closely, then this is the subarray, this is the subarray that has the maximum sum. Okay, so maximum sum is 9. So if you will calculate this, you will find out 9. Okay, because let's suppose if you take this subarray, so this subarray has -3 as the sum, this subarray has what it is, so what 7 minus 6, 1, 3, so 4. So all the subarrays if you will find, and all the subarray sums you will find that 9 being the maximum sum. Okay, now you will be thinking, sir, we have to find the maximum sum subarray. It's very simple. What we can do, there is one array that is given to us, 3 minus 1, 5 minus 6, 3. Okay, just a second. Okay, now what you will say, sir, we will add all the numbers. Sir, we will add all the numbers and the resultant will be the maximum sum subarrays. But this answer is wrong. Why? Because there are negative numbers also in between. Okay, so these negative numbers, once you will start adding, so the entire sum will be less than the maximum sum. Let's just calculate. So 3 minus 1 is 2, 2 plus 2 is 4, 4 plus 5 is 9, 9 minus 6 is 3, 3 plus 3 is 6. So the sum of entire array was 6, but the sum of this sub array was 9. So therefore we cannot add all the numbers. Okay, therefore we cannot add all the numbers. So I hope now the question is clear to you what we have to do. Now let's just quickly jump towards the approach of this question. Okay, so guys, now let's just start with the approach first. So we have this array and we need to find the maximum sum subarray. So what we'll do, we will take two variables. One is the current sum. Okay, let's just denote the current sum with the c dot s. Initialize it with the first element of the array -2. Why first element of the array, I will tell you later. Next variable we will take max sum. So max sum will store, see, lot of subarrays we have. So every these subarray sum, current sum will store, and the maximum sum of the subarray till now, this will be stored by the max sum variable. So it will also be initialized with the first value of the array. Okay, now we have to iterate over this array. Okay, so we will start the iteration from 1 because first value we have already taken. So what we will do, once we are getting the current value, we are simply adding into the current sum. So current sum is equivalent to current sum plus ARR of I. Okay, this is the first step we are doing. So what does our current sum becomes? Our current sum becomes -2 was our current sum, and ARR of I, that is 1. So it has become -1. Okay. The second step we will be doing will be, now current sum, there is some value got that is got added into the current sum. We don't know that whether it was a negative value or it was a positive value. It might be any value. Now the value got added into the current sum. Now we will compare this current sum with the max sum. Okay, so now our max sum will become max of two values, either max sum, previous max sum, or the current sum, because any value was getting added to the current sum. So therefore current sum now might be bigger than max sum, not sure but might be. So therefore now in the second step our max sum value will be updated to max of previous max sum and the current sum. Okay, now in the third step is very important. See guys, now the current sum value is minus 1. Okay, let's just now suppose that we have the array of two elements only. One array is minus 1, one element is minus 1, one element is 98. Now we have our current sum value to minus 1. So even if after minus 1 there are certain positive values that are very large values, so if we try to add those large values into the current sum now, if we try to add them, then the value will become minus 1 plus 98. It will be 97. See, current sum value was minus 1, and when it got added to a large value, then also that large value's value got decreased. It is not 98, it is 97. So if there was an array of two size, I'm just giving you the example, current value was minus 1 and next value is 98. So what will be the maximum sub array according to you? It will not be minus 1 plus 98 equal to 97. It will be 98 only, because a single element also is a sub array. Okay, it is a sub array. Single element is also is a sub array. So the answer of this particular array will be 98. So now what is happening is that, see, our current sum value according to the above logic was minus 1. Okay, was minus 1. Just a second. Was minus 1. Yeah, it was minus 1. So now when we will go to the next value, whether it is large value, whether it is small value, it does not matter. So whenever this current sum value of negative will be added to a positive value, the positive value will always be decreased. It will lose its value. Okay, so what we have to do on the third step, if our current sum value is less than 0, then do nothing but do current sum equivalent to 0. Nothing, do current sum equivalent to 0. So these three steps we have to follow, okay, one by one, and in the end we will be getting the answer. So now let's just quickly do these three steps on our array. So current sum was minus 2 initially, maximum sum was minus 2 initially, and we're iterating over the array from here. So current sum, according to first statement, current sum becomes minus 2 plus 1, that is minus 1. Second step, minus 1 and minus 2 will get compared, and maximum value of among these will be taken. So maximum sum value has now become minus 2 or minus 1, because maximum we are taking. Okay, the third step is that if the current sum value is less than 0, then make current sum to 0. So the updated values after the first iteration will be current sum now became 0, maximum sum now became, but it became minus 1. Okay, the similarly we have to follow the steps for the next one also. So for first one, now we are at where we are. So we are at this minus 3. Okay, we are at minus 3. So again we will do current sum plus current value. So 0 minus 3 is minus 3. Again this minus 3 value will be compared with the maximum value. So minus 1 or minus 3, which one is greater? It is minus 1. Again current sum value, that is minus 3, is less than 0, so it will become 0 only. So after this iteration there are no major changes, so it will remain 0 only. Next we are going to this 4. So we are doing current sum plus 4, that is 4. Now we'll be comparing this 4 with the maximum sum. 4 and minus 1, which one is greater? It is 4 only. So maximum sum will also become 4. So if current sum is less than 0, so it is not less than 0. So this if condition will not run in this case. So updated values have now become 4 and 4 for current sum also and for maximum sum also. Okay, next now move towards the next iteration. So minus 1. So current sum plus minus 1 has become, so current sum has now become 3. According to current sum and maximum sum, which one is greater? So it is 4 only. Okay, if current sum is less than 0, it will not run. This condition will not run. So updated value of current sum has now become 3. Okay, and maximum sum value is 4 only. So next move into this iteration. So 3 plus 2 is now become 5. Current sum value has become 5. Maximum sum between 5 and 4 is 5 only. So maximum value has also updated to 5. Condition, if CS is less than 0, that will not run. Okay, this will not run. So again the updated values will be this will be 5 and this will be also 5. Okay, this will be also 5. Okay, next move into this one. So 3 plus 1, now current sum has become 6. 6 it has become, and now maximum 6 and 6 it has become 6, and then this condition is also not valid, so it will not run. So now our updated values are 6 comma 6 for this iteration. Next we are going to minus 5. Okay, next we are going to minus 5, but should be its output was 6. Okay, so next we are going to minus 5. So current sum plus minus 5 is equivalent to 1. Okay, maximum 6 out of 6 and 1, what is the maximum? It is 6 only, and this if condition will not run because current sum is not 0, not less than 0. So current sum has now become 1. So again moving to the next iteration, so 1 plus 4 has become 5. Okay, 5 current between 5 and 6, which one is greater? It is 6 only. The third condition will not run, so current sum will remain 5 only. So after this iteration over, so we will simply, what we'll do, we will simply return the maximum value, that is 6 only. So our output has come out to be 6 in this case. So you can see our output is coming as 6 in this case. So I hope now the approach is clear to you. It is very 3-step process. This algorithm that we have used here, it is also known as Cadence algorithm also, and it is also an interview important question for Accenture and different companies. Okay, interview all okay, interview also this question can be asked, and this was asked in the coding round as well. Okay, so I was telling you about that why I have taken this current sum and max sum initialized with the first value of the array. So let's suppose we have the entire negative array only, so -2 minus 5 -4 -1. So we have initialized with sorry the first value only. So max current sum was -5, maximum sum was -5. So if we will go towards the next iteration, so -5 plus -4 will become -9. Okay, out of -9 and -5, but which one is greater? It is -5 only, it is greater. Okay, so -5, oh sorry, -9 and -5, yeah, -5 is only greater, and then the current sum is -9, so it will now become 0 for the next iteration. Now we will go to here, so we will do 0 minus 1. The current sum has become now -1. So max sum is -5. So out of -1 and -5, which one is greater? So it is -1. So maximum sum has also become -1 only. Okay, and then current sum will become 0, and we will move towards the next iteration, that is out of the array. So we will return from maximum sum here, that is -1 value. So if in the array there are all negative values, so initializing with the first value will help. So this particular approach is valid for both the arrays, if it containing the positive number or it is containing the negative number. So I hope this particular approach is clear to you. If you have any doubts, you can write in the comment section, and if you are finding this video informative, do hit that like and subscribe button for this particular channel. So now let's move towards the coding part, that is also very simple. Okay, so guys, for saving time, I have already written the code. So this is the Cadence algorithms code. So what I have done, again in Accenture, you will only have to implement the function, not the input and output. Okay, so first array will be given to you, and the length of the array will be given to you. Okay, so input format can change based on them, but yeah. So if n is double equivalent to 0, return 0. This is the base case. So if the size of the array is 0, so you just have to return 0 only. Okay, so then we have two variables, current sum and maximum sum, and we have initialized with the first element of the array. Then we have looped over the remaining elements from I equal to 1 till I less than n, and we have done current sum plus equivalent to error of I. Then we have updated our maximum sum. So maximum sum is equal to max of maximum sum and current sum. Okay, and then if our current sum is less than 0, we have done current sum equivalent to 0, and in the end we have returned our maximum sum. So this is the 3-line step that we have to do, and let's just run it. It should give us 6. Okay, then we'll run the all negative scenario also. Okay, so then in all negative scenario, -5 should be coming. So yeah, it's coming here. So let's say 4 elements are there. So -5, -4, -3, -2 is there. So answer should be. So here you can see that we have got a required output. So this was all for this video. Do hit that like and subscribe button for this channel, and do share this video among your friends also. Okay. So the name of the question here is nearest integer. That is, you are given a function that is int. This is the function that you are given, and you will just have to implement this function. So this is the return type, that is integer is the return type of this function. Nearest integer is the name of the function, and there are two arguments, that is int num and int m. Okay, let's just read the question now. The function accepts two positive numbers. First one is num and another one is m as its argument. Okay. Implement the following function to find the nearest integer to num. Okay. So we are given these two arguments. Now we have to implement this function to find the nearest integer. So now what is a nearest integer? How we have to do it? Let's just read further. Okay. Now how to find the nearest integer? Okay, so the nearest integer is a number that is divisible by m. Okay, so we have the nearest integer is should be divisible by m. So this is our m. The nearest number that we find should be divisible by m. Okay. Next thing is number should be nearest to num. Okay, the number that we find that should be divisible by m, and it should be nearest to this num. So guys, if you have not understood this question, let's just understand with the help of the example. Okay, what does it is saying? It is saying that you are given two input numbers, num and m. Now you have to find a third number. Okay, which should be divisible by m, and that number should be nearest to num. Okay, so I hope now question is clear to you. Let's just quickly see the test cases. It will become things will become more clear. So now see, we have 67 in the first input. We have 67 as our input, and m value is 8. Now we have to find a number. Now we have to find a number which should be divisible by 8, plus that number should be nearest to this 67. Okay, now we have to find the nearest number. You can say that we have to find the nearest number to this 67 which is divisible by 8. Okay, so now we have to find a number that is nearest to this 67 and it is divisible by 8. So there are only two options. One number is 64 and another number is 72. So these two numbers are closest to 67 and divisible by 8. So now since the answer only we have to return one number only. So out of these two options, which one is nearest to 67? Which one is nearest to 67? So how we can find it? We can find it as simply subtracting that number from 67. 67 minus 64 is 3, and 72 minus 67 is 5. So which one is nearest? So this number is nearest since the distance is less. So our answer will be 64. So I hope now the question is clear to you. We are given a number. Now we have to find a third number that is divisible by 8. And it is nearest to the original number, that is 67. Let's just see another example. Okay, next number is 26. Now 26 is given to you, and the number that should be divisible by it should be 3. Now we have to find a number. That is divisible by 3 and it is nearest to 26. Now once it is and it is nearest to 26. So what are the numbers? What are the possible options which are divisible by 3 and are nearest to 26? They are 24 is divisible by 26, and 27 is divisible by 26. Okay, or 27 is divisible by 3. So these are nearest numbers. These are two options. Probability of these are only two options. So now let's just calculate the distance. So what is the distance of first number? That is 26 minus 24 equal to 2. What is the distance of second number? It is 27 minus 26 equal to 1. So which one is nearest? 27 is nearest since the distance is small. So therefore we have written 27 here. So now I hope the question is clear to you. It is a very simple question if you read it carefully. Otherwise you will get confused in the exam. So make sure now to see the approach of this question and the code of this particular question. Okay. Okay, so guys, now let's just see the approach of this question. Now we have to, we were given 67 as our input. So now we know manually that the two numbers that are closest to 67 should be 64 or it should be 72. Okay, we know this by manually, but how we have to write the code for it so that all the test cases get passed. So for that, what we have to follow, we will have to follow the approach that I will be telling you. So now what we have first of all, what we'll do, we will divide these two numbers. And we'll find out the remainder. Okay, we will divide these two numbers and find out the remainder. Okay, let's just see how we will find out the remainder now. So if how we can find the remainder? We can simply find the remainder by r is equal to 67 mod 8. 67 mod 8, or you can say equivalent to num that is given to us mod m that is given to us. Now this particular function will give us the remainder of it. What is the remainder now? Remainder has come out to be 3. Okay, now see, we have got the remainder now. Now what was the main name of the question? We have to find the number that is nearest to 67 and it should be divisible by 8. Okay. Okay, so now we have got the remainder. Now we have to find that which number is closest to it. So what we'll do, we will compare this remainder with this m value. How we will compare it? We will use this particular equation. That is, r should be less than m plus 1 divided by 2. If this condition is true, then we will give the smaller number, then we will return the smaller number. That is smaller number. What is smaller number? It is 64. Okay, else, this was the if condition, if this is true. If it is false, then what we'll do? Then we'll return the bigger number. Bigger number, that is 72. How we will do it? Let's just see. Now let's just compare it using this particular equation. 3 less than m plus 1. That is m plus 1. Why we have taken m plus 1? Because see here m is 8. So m divided by 2 will give us even number. Oh, will give us the correct answer. But what if an odd number appears? That is 7. Let's just suppose m was 7. So 7 plus 1 equal to 8 divided by 2. Okay. So now it will give us 9 divided by 2. Okay, it will give us 9 divided by 2 because m plus 1, 8 plus 1, 9, 9 divided by 2. Now, 3 less than, what is 9 divided by 2? 9 divided by 2 is 4 in the coding language. You do not have to write 4.5 here. 9 divided by 2 is 4 only. Okay, now this condition is fulfilled. Now, once this condition is fulfilled, see, this condition is fulfilled, it means we have to return the smaller number, that is 64. But how come we will reach to this 64? Because we only have 67 with us and 8 with us. How come we will reach with 64? By this condition, we just know that we will have to we will have to return the smaller number. But how we will return the smaller number? So we will return the smaller number by using this equation. That is, once this smaller number equation is fulfilled, we will simply return that is a num, that is for 67 minus r. Returning smaller number is easy, that is 67 minus r, that was 3, it will equal to 64. So we have simply returned this particular answer if this smaller condition was fulfilled. What if this was a false condition? Let's just see. See, you have seen this particular thing. Okay, you have seen this particular thing. This was for the first input. Let's just see for the second input now. What was our second input? Let me just write here only. Okay, second input was, what was num? Num was equivalent to 26. What was m? M was equivalent to 3. So now what we'll do, we will first of all find the remainder of it. What was the remainder? So let me just do this. What was the remainder? It will be 26 mod 3. That will give you 2. Now again we'll compare this remainder in this particular equation. We put the remainder in this particular equation. That is r less than m plus 1 divided by 2. What is m? What is r? R is 2 less than m plus 1. M plus 1 is 3 plus 1. It is 4. 4 divided by 2. So this equation will be 2 divided by 2 is less than 2. Okay. So is this condition true? Is this condition true? No, it is not true. It is false. So now we have encountered this particular condition. Once it is false, we know that we will have to return the bigger number. Because see, here also two possibilities were only there. There was 64, there was 72. Here also two possibilities are only there. One is smaller number, that is 24. Another one is bigger number, that is 27. Now, since this condition has returned false value, that means we know that we will have to return the bigger number. Bigger number is 27. But how come we know that 27 have to be returned? Because we only have 26 and 3 with us, how come we will get to 27? So what we'll do, we'll simply do, what was our given number? Our given number was 26. See, in the smaller number, we were returning simply num minus of r, num minus remainder. But if the condition of false is correct, that is bigger number we have to return, then what we'll do, we will do num plus m that was given to us minus r. Okay, that what was our num? Num was 26. What was our m? M was 3. What is our r? R was 2. 26 plus 1, 27 here. So therefore we have returned this particular thing. So first of all, we will have to check we will have to find remainder. We will check that remainder with the m value. If the m value gives true, it means that we will have to return the smaller value. How we will return the smaller value? By using this formula, that is num minus r. Num minus r was used to return the smaller value. But if the condition returns false, then we will have to return the bigger value. So how we will find that bigger value? That will be using this formula, that is num plus equivalent to m minus of remainder. Okay, this will give us 27 here, and this particular condition will give us 64 here. So this was the entire question and the entire approach. I hope the approach is clear to you, because it was a very simple approach that you can think of. Okay, and guys, one more thing you must be confused, that why I have chosen less than only, why not less than equal to? Because in the question it is given, see, it is given if there are two numbers with least distance from num. If there are two numbers, and we know that for all the numbers only two possibilities will be there. So if those two possibilities are at the same distance, then we will have to return the larger number. So if in this case you can see 2 is equivalent to 2. So therefore it means that distance of both the numbers are same. So therefore we will return the bigger number. So therefore we have returned 27 here. Okay. So I hope now the question and the approach is clear to you. Now let's just see the coding part of this particular thing. We have to write. So as for saving time, I have already written the code. It was a very small code. Just the understanding of the question is required. Okay. So again, in the Accenture, you just have to implement the function. You do not have to take input by yourself. They will provide you. Just you have to implement the function. Okay. So what I have done, first of all, I have calculated the remainder. How? Num mod m, as I have told you in the approach. I have calculated the remainder. Now I have checked the if condition. That is, if our remainder is less than m plus 1 divided by 2. Why we have taken m plus 1? Because of the odd number. Suppose m was 7. So 7 plus 1 divided by 2 will be easy. Okay. So therefore we have taken the m plus 1 divided by 2 for the odd numbers. Okay. So if this condition is fulfilled, that means we have to return the smaller number, because we have only two options in the to find the nearest integer. That is, if we take number 67, so only two options are there. For any number, two options are only there. One is smaller number, one is the bigger number. Okay. So for 67, it was 64 or 72. Okay. So once this if condition is fulfilled, that means that we will return the smaller number. How we will reach the smaller number? We will simply, what we'll do, we'll simply subtract remainder from number, input number. Okay, by this we will return the smaller number. Now if this if condition is not fulfilled, then we will have to return the large number. And how we will return the bigger number? We will simply use the formula for num plus m minus of r. So this will return the bigger number. Okay, let's just run on the certain inputs. Let's just run on the certain inputs, where our num was 67 and our m was 8. So in this case 64 should be returned. Okay, let's just see whether it returns 64 or not. And next input we will take 67, and let's just suppose okay, it is returning 64. Okay, now let's just take 69 as 68 as input. Okay, 68 as input. Now see, both the numbers have both the numbers that both the options, that it was 64 and 72, now have the same distance from the 68. So let's just see what number it will return. Okay, it should return 72 ideally. Let's just see what our code returns. So you can see it returns 72 only, that is the larger number. 64 and 72 had the same probability, same distance. So therefore in the question it was given that if two numbers are at the same distance from the input, then return the larger number, so therefore we have returned the 72 as our output. Okay, let's just see next example, that was 26 and m was 3. So in this case we should return 27. In this case 27 should be returned. So let's just see what does our code returns. So you can see here 27 returns, because 27 has the least distance between with 26. Okay, so guys, this will pass all the test cases that will be given to you. So question here is, unique path states that the given the m into n grid, where a robot starts from the top left corner of the grid, we need to find the total number of ways to reach the bottom right corner of the grid. The robot can only move either down or right at any point of time. So guys, this is the same question we have seen in lead code also. Okay, so sometimes what happens that in Accenture the coding questions are directly from lead code, Geek for Geeks platform. So it is not of a like anything new, or you will say that okay, this is a lead code question only but it's new in it. So there can be a scenarios where the question gets directly picked up from lead code or Geeks for Geeks. Okay, that is a fair scenario. So here what we have a grid of m into n size. Okay, m are the rows, and n are columns. So we have a robot at this point. Okay, at this point we have the robot and it has to reach this point. Okay, and we have to calculate the total number of ways in which he can reach the top bottom right corner. Okay, he will start from top left corner and we have to reach towards the bottom right corner. Okay, now in this particular scenario, it is given in the question that robot can only move either down or right. So either the robot can move right of it or the robot can move down of it. Okay, and there is one more condition given, and there are some cells containing obstacles which are represented by 1 while 0 for free cell. So there are certain cells inside this matrix. If you can see this cell, so this contains 1, that is, this is an obstacle, so robot can never pass through this side. Okay, so if it is 1, so he will have to try a different route, okay, to reach the bottom right. So if there is a 1 in any of the obstacle array, so it means then it means that here it cannot go and it has to take the another route. So this is the entire question. Let me just quickly explain again. So there will be an m into n matrix given. There is a robot at the top left corner. The robot has to go to towards the bottom right corner. Robot can either go right or robot can either go down. Okay, and total number of ways we have to find in which it can reach from top left to top right. And there can be certain obstacles also inside this matrix. Through that route the robot cannot pass. Okay, so I hope now the question is clear to you. Now let's just quickly see with the help of the inputs that how the answer is coming. So yeah, so this is the matrix that has been made. Okay, this is the obstacle. Robot has to move from here to here. Okay, so what is one path? So one path is from moving from this to this. Okay, one path is from moving to this to this. Second path is that it uses this route to move it. So two we have found. Now there is one obstacle in the middle also. If there was no obstacle in the middle, then this was also a valid path. Okay, this was also a valid path. And if there was no, yeah, so this path also was valid, so then we might have got more than two. So let me just explain again. If you are got confused, let me just make a matrix again. Currently the matrix is given to us like that. Okay, here is the obstacle, here is robot, he has to reach here. So one best path is to reach from here to here. Second best path to reach is from here to here. Next path was, see if you will look clearly, the next path was from here to here to here to here, but we have an obstacle in between, so this path cannot be traversed. Okay, another path was that was possible was from here to here till here till here, but again there is an obstacle in this particular cell, so this robot can never go inside this cell. So always in every scenario there are only two clear possible paths that are given to us, that is one is this one and another one is this one because of the obstacle. So therefore the answer is 2 here. So I hope now the input is clear to you. Next, let's just see next example. So again we have a matrix here, 2 by 2 matrix we have. Okay, 0 is here, 1 is here, 0 is here, 0 is here. Okay, so now robot is here, it has to reach here, the obstacle is here. So one path is to from moving here to here, this is one path. What is another path? Another path was from here to here, but there is an obstacle here, so this path cannot be taken. So never, the robot will never go inside this cell. So this path cannot be taken, and there is no other possible way of going it, because the robot can either go to right, either go to down, not diagonals. So therefore only one path is possible here. So I hope now the question is clear to you. Now let's just quickly move towards the approach of this question, and lot more things will become clear to you. Okay, so guys, two examples we will be seeing, and everything will become clear to you with the help of code also. Okay, so what we have an obstacle array that is given to us 0 0 0 0 1 0 0 0 0. This is one stands for this cell is an obstacle. Now what we'll do, we will make a new array. Okay, and we will fill cell by cell. At every cell, what we'll do, at every cell we will check that how many ways from here. Okay, let's suppose, just for an example, if we are here, we will check that there are how many ways from this cell to reach towards the top bottom right. Okay, bottom right. If we are at this cell, there are how many ways to reach from this cell to bottom right. So if you will look closely, we have only one way of reaching it. So the value at every cell will denote, in the new array, will denote the number of ways from that particular cell to bottom right. I hope this is clear to you. Again, if we are at this cell, okay, this was the obstacle, if we are at this particular cell, then from there are how many ways from this cell to reach towards the bottom right corner. So there is only one way, that is it can go like this and this. So this is all, there is only one way from this cell to bottom right corner. So the crux of this thing is that we will start filling the new array, and at every cell of new array we will check that there are how many ways to reach the robot from the current cell towards the bottom right. So this will be going to be a proper approach for it. Okay, now see how we will start filling the array. So we will start filling the array from the last cell, from the bottom right cell only. So let's suppose now the robot is at this cell. So robot is at this cell. So there are how many ways for a robot to move from this cell to reach the bottom right. So there is only one way. Okay, because the robot currently is at this cell. Okay, robot is currently at this cell. How many ways are there for a robot to move from this cell to the bottom right? So there is a one way only. So we will fill one here. We will fill one here. Okay. Now the robot is at this cell. Now there are how many ways for a robot to move from this cell to bottom right? So there is only single way to do this. Okay, so therefore this cell will also contain 1. Now robot is at this cell. Okay, now robot is at this cell. So there are how many ways for a robot to move from this cell to the bottom right? So only there is one way to move down only, because it cannot go right, it will become array out of index. So from this cell to reach towards the bottom right, there is only one way. Similarly, if the robot is at this particular cell, there are how many ways of reaching from this cell to the bottom right? There is only one way, that is this one. Again, again, the robot is currently is at this cell. How many ways are there from this cell to reach at the bottom right? That is this. Okay, there is only single one. Now the robot is at this cell. There are how many ways? Okay, there are how many ways for the robot to reach from this cell to the bottom right cell? From this cell to the bottom right cell. The answer will be 0. Why 0? Because this is an obstacle point. Okay, this is an obstacle cell. The robot will never reach this obstacle cell. Okay, the robot will never reach this obstacle cell. Okay, and if it is at obstacle cell, from there to move towards bottom right, it is always 0. Okay, now see, we have filled the matrix last row also and last column also. Okay, now there will be a pattern that you will be noticing. There are how many ways a robot can move from this cell to reach towards the bottom right? How many ways for the robot to start from this cell and reach this cell? How many ways are there? So we know that robot can go towards right also and robot can go towards down also. So till now the right and down was not possible, both of the scenarios were not possible. We were at this line, so here only down was possible, not right, because it was going outside the array. And when we were here, the robot can only go right, it cannot go down because of the out of bounded array. So now at this particular cell, this is the first where the robot can either go right also and it can also go down also. So there are how many ways? So total will be, if the robot goes down, then there are how many ways? Then there were 0 ways. Okay, from 0 ways to reach towards the bottom right. And if the robot goes right, so there were how many ways? So there were one way. That okay, so from one way was there. So from this cell, what will be the answer? This cell will be array of ij, that is the current cell, will be equivalent to number of ways is arr of I plus 1 j plus arr of I j plus 1. So this cell value will be defined by this value plus this value, that will be 1 only. Okay, let me remove this. I hope this is clear to you. Because see, once the robot is at this particular place, it can go to right, so it will go to this cell. Okay, it will go to this cell. How many ways from this cell to reach bottom? We have already calculated as 1. If the robot from this cell goes down by one step, so it will reach this cell. Okay, then how many ways from this cell to reach to bottom right? There is 0, we have already calculated. So total number from this cell, it means that total number will be arr of I plus 1 j, arr of I j plus 1, that is this plus this, equivalent to 1. Similarly, if I call out this cell, so again the same thing will happen. So at this cell, what will be the total number of ways from reaching from this cell to this cell? Okay, from reaching this cell to this cell, it will be again this formula we will be calculating. So this value and this value will be adding, this will be 1. Similarly, now we are at this particular cell, so again 1 was here. So again, how many ways are there from reaching this cell to this cell? From this cell to bottom right, so again this plus this, that is 2. So the entire formula that we are using to fill the entire new array is this formula. Okay, this formula, arr of I plus 1 j plus arr of I j plus 1. Okay, and in the end, the value that is present on the dp of the new array arr of 0 comma 0, the value that is present here, that are the total number of steps. If you will look closely, so 2 was our output. So I hope now things are clear to you. Now let's move towards the next example, then the things will become more clear. So okay, so guys, now let's see the next example. The things will become more crystal clear to you. And if you are finding this video informative till now, please do hit that like and subscribe button for this video. It gives us immense motivation. And do join the Telegram group also. The links you will find in the description box. So now let's just see this example also. And we have calculated a formula in the previous example that arr of I j is equivalent to arr of I j plus 1 plus arr of I plus 1 and j. This is the formula that we have calculated in the previous example. Now we will be using this formula to fill the new array. So first of all see this is a DP question if you remember. Okay, so we have to fill the base case. So what is the base case? Base case is the bottom right corner only. That if the robot is at the bottom right corner, how many ways are there to reach to the bottom right? If it is only at bottom right only. So the answer is 1. So this was our base case. We will first have to check that whether there is an obstacle or not here. So we can see that there is a 0, so there is no obstacle on this particular point, and therefore there is a one way of doing it. Okay, if there was obstacle, we will simply put 0 here. Now we will move towards this part. Okay, then move towards this cell. First step will always be to check that whether there is an obstacle in this cell or not. This is a new array we have found, there is an obstacle array also. First step will be to check whether there is an obstacle at this point or not. So here you can see that yes, there is an obstacle at this point. So just blind the eye and just write 0 because currently at this cell there is a obstacle. Now we go towards this cell. Okay, so this cell represents that there are how many ways from this cell to reach towards the bottom right. So we will use this formula. So once you will using this formula, you will see that there should be a value at here also, and there should be a value at this cell also to use this formula. But this is out of bound. Okay, this is out of bound. Okay, because we are doing j plus 1, so this j plus 1 will move here. So this is out of bound, and we are doing I plus 1 also, so I plus 1 will go down. So this value is present. So when this scenario happens that one of the two values are out of bound, then we will take only one value that is present. So this 0 value is present and another value is out of bound. So we will what we will do, we will do 0 only, because the value that is present, in case that there is one out of bound value, the other value that is present, we will simply take that value in the current cell only. Now we are at this particular cell. Again, we'll follow the same approach. ARR of I j plus 1. So j plus 1 will be this value. Okay, and then plus ARR of I plus 1 j. So I plus 1 will be this value that is out of bound. So I have told you, first of all, let's check that whether it is at this cell there is obstacle or not. So there is no obstacle. So then we will move towards this formula. So in this formula, there is only one value present, that is ARR of I j plus 1. So this value is present, another one is out of bound. So we will simply take this value only, that is right side one only, and we'll move above. Now we are at this particular what you will say, cell. Now again, first of all, we'll check whether there is an obstacle or not. So you can see there is an obstacle, we'll simply put 0 over here. Now we move towards this particular cell. Okay, we'll move towards this particular cell. Now we will be using this formula. There is no obstacle, we will be using this formula, AR of I j plus 1. So this value is present, you can see, and AR of I plus 1 j. So this value is present. In this case, both the values are present. So we'll simply take both values and add it. Okay, so the answer will coming out to be 0 here. And so we have filled the entire array. So total number of ways that we need to return is dp new array 0 comma 0. So what is the value? 0 only. So 0 is the total number of ways for this particular array. So if you will see manually, then you will not find any way from reaching till from here to here. You will find no way because there are obstacles in between. So I hope now the approach of entire thing is clear to you. Okay, approach is clear to you. This formula we will be using, keeping in mind out of bound index also and obstacle also. And now we will move towards the coding part. So I hope now you are understanding that things are become more clear, and do hit that like and subscribe button before moving ahead. Okay, so guys, for saving time, I have already done the code. So many of you were asking me on the Telegram group in Accenture that whether sir we have to write the input function also, or only we have to we will be given a function and we have to implement the function. So answer is that you will be given a function and you have to implement the function only. So you will be given the input parameter in the function and you have to do operations based on that only. So no need to worry about taking input. Okay, so I hope this is clear to you. Next is obstacle read, we have our input. So first of all, we will be finding how many rows are there. Okay, so guys, one thing I want to tell you, see here, the main purpose of this video is to explain you the concept. Okay, I'm not like telling you that this is the exact input format that will be given to you in the Accenture exam. There might be different formats, so based on that the code will change. Okay, you can't just see this video and just hope that if the same question come, I will just copy paste this code to Accenture exam. That is not possible. So the input structure can differ. You have to change your code based on their input structure. So moving ahead, so we are given the input as obstacle grid. So first of all, we will be finding that how many rows are there. So n is the number of rows. Okay, we have found like this. And if our n is 0, so the total number of total number of ways are also 0. Then we'll find the number of columns, that is m. So this is how we'll find the number of columns. And if our columns are also 0, so we will straight away return 0 only. Now see, now there is one base case that I have told you, that first of all what we'll do, we will start by filling the last, bottom right cell. So what if the bottom right cell only is contain obstacle itself? So then there are 0 ways to reach the last stage. So if I will tell you with the help of example here, see the what is the base case. So let me just insert one row. Okay, insert table 3 3. Okay, so if there is an obstacle on the last column itself, then how many ways are there from this to reach this? So there are 0 ways only, because last column, that is bottom right cell, only contains the obstacle. So if our obstacle grid last column contains 1, then we are returning 0 here. Okay, then we are returning 0 here. Okay, so next what we are doing, we are making a new, sorry, we are making a new array, 2D array, or you can say vector also. You can make vector or you can make array only based on your understanding. So we are making a new array, 2D array. We will fill this array with the number of steps. What we'll do, we will iterate over the array from I is equivalent to n minus 1, I greater than 0, I minus minus, j is equivalent to m minus 1, j greater than equal to 0, j minus minus. So I have told you that we will be filling array from bottom towards the top. From bottom right, we will be filling the array towards the top left. So therefore the loops are opposites. Okay, it is not simple while loops like I0 till I less than n, but we are filling the array from bottom right to the top left. Okay, okay, so at every index, now the next step was, at every index we will be checking that whether the current index contains obstacle or not. Okay, if the current cell contains obstacle or not. If it contains obstacle, then simply we will place 0 there, that okay, from this cell to reach top bottom right, there are 0 ways to go. But what if there are no obstacle in the current cell? So if there are no obstacles in the current cell, then there are again four conditions that I have already told you. So the major logic will remain same. So the main logic will remain same, that error of I j is equivalent to error of I j plus 1 plus error of I plus 1 j. This is our main logic that will remain same. But as you know, there were few scenarios in which we were going out of bound. So in some cases we were going out of bound in the case of column, and in some cases we are going out of bound in case of rows. So that thing we need to check. So if I plus 1 is less than n and j plus 1 is less than m, so it means that from both rows and column perspective, we are not going out of bound, and our simple formula can run. That is dp of ij, dp I plus 1 j, dp I j plus 1. So this is the case when we are not going out of bound in any case. Okay, no out of bound. This is the case where is no out of bound is happening. Okay, next case is that in which we are going column out of bound. So in which we are going column out of bound. So this is the condition here, that our row is correct. Okay, row is correct. I plus 1 is less than n, that is our row is correct, but our column is going out of bound. J plus 1 is double equivalent to n, starting with 0 index. So in that case, what we are doing, when once we are getting the column out of bound, so we were just, okay, so just a second. Okay, so this was out of bound and this was the correct row. So we were taking the correct row only, correct row value only. So in this case, what we'll do, dp of ij will become dp, the same value of dp I plus 1 j in the case of out of bound. Okay. Next was we were doing row out of bound, row out of bound. So in this case, what we are doing, so dp of ij will become same as dp of ij plus 1. That is the column value that was there. We will simply take that only in case of row out of bound. In case of column out of bound, we will take the value of row. Okay, I plus 1, that is the row. And in column, row out of bound, we will take the value of column only. Now the next case was where are both row and column are out of bound. So which case was that? That was not discussed in the video. Yes. So this case, that is the last cell. I have told you that last cell will always be 1. Okay, if there is no obstacle. So if there is obstacle, we have already written 0, but then next means it is next means that there is no obstacle. So if there is no obstacle on the last column, then we will be returning 1. Okay, we will be placing 1 there, because if the robot is at the bottom right cell, then how many ways are there to reach bottom right? So there is one only. So if both row and column are going out of bound, then it means we are at the last cell, bottom right cell. Therefore dp of I plus 1 j, dp of ij is 1 only. Okay, so I hope this is clear to you. And once this for loop is done, so all these operations will be done on every cell. Okay, all these checks will be done on every cell. And once this for loop is over, we will be simply returning the first value of the array, that is dp 0 comma 0. So let's just now look for some examples. So 3 3, okay, 3 3, and yeah, so 0 0 0 0 1 0 0 0 0, sorry, yeah. So we will run it and we'll find that there should be output as 2. If you have like found this video informative till here, please hit that like button. Okay, so you can see our output is 2. Let's just now see when there are 3 rows and 2 columns. In that case, what happens? Okay, that we have seen one example. So yeah, so in this case, 0 should come as the output. So yeah, 0 is coming as the output. So as this, in this particular code, all the base cases I have covered. Just that if it comes same in the exam, then you will have to modify based on the input they have given. But every logic will remain exact same. So I hope now the question was clear to you, approach was clear to you, and code was also clear to you. If you have any doubts, you can write in the comment section, and do join the Telegram group also that I have given in the description box and in the pinned comment, because it will be a lot of discussions are happening there. So question here is, Alice has to climb n stairs to reach the top. Alice has to climb n stairs. Okay, in each step Alice can climb either one step or m steps. Find the minimum number of steps to reach to the top of the stairs. Okay, so let's just see the input format. Input contains two space separated integers n and m. So n are total stairs and m is the integer value that how many steps at once Alice can climb. Okay, output format is, it contains the integer that represents the minimum number of climbs required to reach the top, that we have to find. Constraints are, our n is from starting from 1 till 10 to the power 9. M is also from 1 to 10 to the power 9. So it means the maximum time complexity that we can use in our solution is big O of log n. Okay, this is the maximum time complexity we can, oh sorry, not log or log of n, sorry. So the maximum time complexity that we can achieve is n. Okay, big O of n. Okay, so we cannot go to n square, n log n, or n cube. We have to, like, maximum time complexity is big O of n because of the constraint. So let's just see the input and output first. So let me just so there are 5 stairs that are given. So this is n, this is m. Okay, so there are, the input here is 5 is 2, n is 5 and m is 2. So n is number of stairs and m is the how many stairs at a time he can climb, Alice can climb. So let me just draw the stairs. I know, man, for many of you the question is not clear to you. 1 2 3 4. So 1 stair, 2 stair, 3 stair, 4 stair, 5 stair, and he has to reach to the top. So starting from here, so he has to reach the nth stair, that is last stair. So starting from here, what he can do, what are his options? He can either jump 1 or m stair. So m is equivalent to 2. So from here he can either jump 1 or he has to jump 2, and there should be a minimum number of uh, jumps, minimum number of climbing that needs to be happen. So first he does 2 jumps, then again he does 2 jumps, then he does 1 jump. Okay, then he does 1 jump. So again, let me tell you, first he does 2 jumps, then again 2 jumps, then 1 jump. So total 3 jumps are there, 1, 2 and 3. So therefore our output is 3. So from starting from 0th stair, it has to reach the last stair, that is the nth stair, to the top. Okay, so 2 jumps, then 1 jump, because m was 2. So I hope now the question is clear to you. We have to find the minimum number of jumps that Alice has to take to reach the top of the stair. So now let's just quickly move towards the approach. So approach will be very simple for this particular question. So what we'll be doing, we will be using an approach algorithm called greedy algorithm. Okay, greedy algorithm we will be using. So see, Alice has two options at every stage. Either he can climb 1 stair or he can climb m stairs. And but we have to find the minimum number of jumps we have to find. So what we do, okay, we start with jumping m times. So here n is equivalent to 5, so 5 stairs are there and m is 2. We start by jumping m time. That is, we like jump 2 stairs at a time. Okay, so this is one jump. Then again at this point we have two options, either we can take one or we can take m jumps. So again let's just take m jumps only. So m jumps again we take, we reach to this stair. So again this is counted as one jump. Now at this again we have two options, one jump or m jumps. But if you will look closely, that m is now 2. So if we have to reach the last stair. Okay, if we will jump m times, so we will go beyond it, we will go beyond the array, so it will give us index out of bound array. Okay, it is not a valid jump. So at this point we only have one possibility, that is to use one step at a time. So this is also one jump. So here the answer will be 3, as we can see in the above input. Now let's just see with 10 3 with n equal to 10 and m equal to 3, then what will be the scenario? So again two options are there, so either it can take one jump or it can take 3 jumps at a time. So starting from here again we are using the greedy algorithm, so we will take the m jumps. Okay, because we have to find the minimum jumps only. So first let's just start by taking the maximum jumps possible. So at this stage we have both the possibilities, one jump also we can take and m jumps also we can take. So we are taking the m jumps because maximum jumps we have to cover. So this is counted as one jump. Now at this stage also we have two possibilities, either one jump we can take and or 3 jumps we can take. So again we start by taking the 3 jumps. So again one jump has been counted here. So again at this point also we have two options, either we can take one jump or we can take 3 jumps. So again for the greedy purpose we are taking the 3 jumps. So again it will be counted as one. Okay, one move. Now at this stage we only have one option, because if we will take 3 jumps at this stage then we are going out of bound, so that will give us the error. Okay, that is a not a valid move. So at here at this stage we only have one option to go to take one jump and go to the nth stair. So this is also counted as one. So here the answer will be 4, that minimum 4 jumps are required to reach the top of the array, top of the staircase. Okay, so to simplify what we can do is to simplify this. So let me just add one more thing here, one more stair also, that this is the nth stair. So at this point, when we were at this point, okay, let me remove this. So when we were at this stage, we had again either one or three we can take, but three is not a valid move because still we are going out of bound. So we can take one jump. So by one jump we will go going here. Okay, and by again at this stage again we have only one option left. So again we can go one jump and we can go here. So when n is equal to 11 and m equal to 3, the answer will be 5. Okay, so just wanted to make you one more test case. Okay, so if you will look closely, what we were doing, we were uh, we were taking, so to summarize, we were taking m jumps till it was a valid move. Okay, m jumps till it was valid, and once m becomes invalid, we started taking one jump we started taking at every iteration. So just understand this concept. So when we were giving the opportunity, so till we were taking m jumps as starting till it was valid, but once m becomes invalid we started taking one jump at a time only. So how many m jumps we can take? Okay, starting with m jumps, how many m jumps we can take? So we have total n number of n stairs are there, total how many m jumps we can take? So simply n divided by m will give us total m jumps. Okay, and then how many one jumps we can take? How many one jumps we can take? Okay, so that will be n mod of n m, because if you will look closely here in the above scenarios, so how many m jumps were there? So 5 divided by 2 equivalent to 2, so 2 m jumps were there, this was this. Okay, and how many one jumps were there? It was n mod, oh sorry, 5 mod of 2, that is 1. So there was one jump. Similar was the scenario here in this case also. So how many m jumps we took 10 divided by 3, that is 3. So 3 m jumps were taken. And how many one jump was taken when n was 3? So that was 10 mod 3, that is equivalent to 1. So this is our code, this is our logic that is coming through. So how many one jumps we take? N mod m. and total will be, total jumps will be, so let's suppose this is A, let's suppose this is B, so total jumps will be A plus B. Okay, so n divided by m plus n mod m, this will give us total jumps that we need to take to reach the top of the stairs. So I hope now this logic is clear to you. Okay, if you still have any doubts, you can revisit this approach again, or you can move ahead and see the coding part of this particular question. Okay, so guys, I have already written the code. It's very simple. See, in Accenture, you won't have to take your entire input by yourself. You will just be given a function, okay, and you have to implement that function only. This is the function that will be given to you. You have to implement the function. So two arguments will be given, n and m. So I have told you we have to first calculate the m number of jumps, and then we need to calculate the one number of jumps. So m jumps we are calculating n divided by m. So I have already told you why, and one jumps we are calculating n mod m. Why? I have already told you. So we are simply returning the sum of them. Okay, and if you try to run this particular test case 10,3, so it should give us 4 as an answer. Let me just run it. Then we will run 5 and 2 also. So n is 5 and m was 2. Okay, so 5 and 2. Okay. So guys, if you found this video informative till here, or you want to see more videos, you can write in the comment section. So see here 3 is coming. So it will pass all the test cases that will be given to you. The question here is, given an array of length n, find the length of the largest subarray which contains equal number of zeros and ones. Okay, let's just quickly understand with the help of an example. So we have here input as 1 0 triple 1 double 0. So first of all, those who do not know what are subarrays, let me just tell you, subarrays are the contiguous parts in the array. So this is a subarray, this is also a subarray, this is also a subarray. But if you will say that this yeah, just a second, yeah, but if you will say that this 1 and this 0, is it a subarray? So no, it is not a subarray. Okay, so subarray is the contiguous part of elements in the array. So I hope now this is clear to you. Now in the question, what they are asking us, they are asking us to find the length of the largest subarray which contains equal number of zeros and 1. So length of the largest subarrays, but it means that there can be one or more subarrays in which there are equal number of zeros and 1. So first let's just find all the subarrays in which the zeros and ones are equal. So this is one such subarray, this is one such subarray, okay, and this is one such subarray, and this is one such subarray. Okay, so in all these subarrays there might be more here, but in all these subarrays the number of zeros and ones are same. Okay, so here the length is 2, here the length of the subarray is 2, here the length of the subarray is 4, sorry, and here the length of this subarray is 6. So out of these all the subarrays, what is the length of largest subarray? It is 6. So therefore our output is 6 here. Okay, so here you can see that equal number of zeros and ones are present in this particular subarray. Let's just see with one more example. So 0 0 double 1 0. So here also we need to find the length of the largest subarray which contains equal number of zeros and 1. Let's just first make all the subarrays which contain equal number of 0 and 1. This is one of the subarray. Okay, this is one of the subarray, this is one of the subarrays, and this is also one of the subarrays in which the length zeros and ones are equal. So here the length is 2, here the length is 2, here the length is 4, here the length is 4. So what is the largest length? So answer is 4. So therefore the output is 4. Now I hope the question is clear to you. Now let's just quickly jump towards the approach of this question. And the approach of this question, through the approach of this question, we will learn two important concepts and one data structure that will be involved in solving this question. So now let's move towards the approach. Okay, so guys, we will be learning two things here. Okay, two things we will be learning here. One is a new data structure. Okay, that is a hash map. And second is the new approach. Okay, new, like you can say an algorithm or an approach, that is the prefix sum approach we will be following here, and we will be learning that. Now what is a prefix sum? So before moving to prefix sum, what we will do, see, we will take a sum variable, let's just initialize it with 0 only. Now see, this is an array, we will be traversing this array. So we will make one condition, that if the current element is 0, then we will add -1 to the sum. If the current element is 1, then we will add 1 to the sum. Okay, let's just make this condition. Okay, if current okay, let's just just learn this condition that if it is 0, then we'll add -1, and if the current element is 1, then we'll add 1. So what it means, what it means, okay, it means that if a subarray will have equal number of zeros and one, if there is a subarray, let's suppose this is a subarray, if it is having equal number of zeros and ones, then what will be the sum value? Sum value will be 0 for this subarray. So this is just one concept I wanted to tell you, because here -1 will happen, -2 +1 will happen, and it will become 0. So if a subarray has sum 0, it means it has equal number of zeros and ones, because we are for 0 we are adding -1, and for 1 we are adding 1 in the array. Now what we'll do, we will be using prefix sum approach. What does prefix sum approach means? Start iterating the array. Start iterating the array like this. First of all, we are at index 0. We will add this. We will add this into the sum. So sum value, I have told you that when we will get 0, so we will add -1 into the sum. So sum here will become -1. Okay. So what does this sum means? So this sum means that the um, the sum of the array till here, has sum as -1. Okay, so this is what it means. Next thing, okay, moving ahead. Next thing, we will move to the next element. So now the sum becomes now what we'll do, now it is the current element is 1. So sum was -1, so -1, I have told you that when we'll encounter 1, we will add 1 to the sum. So -1 was its earlier value, now we will add 1 to it, now it will become 0. Now what does this sum represents? This sum represents uh, the sum of the elements till here. So these two elements sum it represents. Okay, so moving ahead to the next element. Now again also it is 1 only, so we will add 1 to the sum. So sum, we will add 1. Now the sum becomes 1. 0 plus 1, it becomes 1. Now what does this one represents? This sum represents the sum of the elements till here. Okay, so 0 1 1, so till here it represents that, okay, the sum value till here from the starting of the array till the current element is 1. Okay, now moving ahead. Now again we are coming at sum, just a second, yeah, so now there is 0, so we will subtract it from the sum. We will subtract -1 from the sum. So earlier sum was 1, we have done -1, so it has become 0. Now what does this 0 represents? This 0 represents that the element sum till here from the starting of the array is 0 only. Why 0? You can see, you can already see that there are equal number of zeros and ones, so therefore what is happening, therefore the sum value till here is 0 only. Now next value is again 0. Okay, so there is a variable called sum. Okay, again 0, whenever we encounter 0, we will do -1 to the sum. So now 0 -1 becomes -1. But does this -1 represents? This -1 represents the sum of the array elements till here, that is the end of the array only. Now this is the prefix sum. Now one thing you will be observing, I have already told you that at every step, what does this sum value represents? At every step, what does this sum value represents? So now one thing you can notice here, that there are certain cases wherein the sum values are same, Okay, so what does this means? See, what does this sum value means for -1? It means that till here, the sum of the elements is -1. Okay, so in between these two sum values, what is the sum now? Okay, just try to understand this thing that I'm trying to say. Sum is -1 here, sum is -1 here. So what does this means? That from elements till here, from here till here has sum 0 only. Let it digest. What does this sum value represent? It represents the sum till here. What does this value represent? It represents the value of sum till here. Now, if both the value of sums are same, then it means that between the elements, between the array, from this index till this index, the sum is 0. The sum is 0. Okay, because there is no addition or subtraction happened here. So therefore, starting from this index till this index, that is from these elements, the sum is 0, because the sum value is same here. Okay, you can see this is the case with other thing also. Other case, if you will try to take, the things will become more clear. Okay, so this 0, if you will see, this is also 0, this is also 0. So what does this sum represents? This sum represents the sum of the elements still here. This sum represents the sum of the elements still here. Okay, since the sum values are same, it means from these two elements, from this element to this element, the sum in between is 0. So sum is 0 only because the values are same. And when sum is 0, it means that there are equal number of ones and zeros. So here you can see there are equal number of ones and zeros. So this is how we can find the length of the array. Okay. Now we will come to the hash map. That what is the use of hash map here? See, what we are doing, we are iterating the array from left to right. Okay, from left to right, we are iterating the array. We know that okay, the here 0 comes, here 1 comes, here 0 comes. But how do we know that already this -1 has came, already this 0 has came? So how we'll find that sub array? So therefore we will be using the hash map here. So what is a hash map? Let me just quickly describe it. So hash map is nothing but a key value pair. Okay, key value pair. So key by key there, for every key there is a certain value. What we will do, what we will do while we are traversing over the array. Okay, now I am going to the actual approach. While we are traversing over the array, we are calculating the sum, prefix sum we are calculating. We will first check whether that prefix sum is already present in the array or not, already present in the hash map or not. If it is not present, we will add it in the hash map. If it is present, then we'll do other step. Let's just now see that thing. Okay, we will form a hash map. Currently, initially, what it will happen, it will contain the value. So we are forming a hash map of key value pair. Initially, there will be one key that is present, that is 0, and index will be -1. Why -1 I have taken? I will describe you later that why this is the base condition that I am taking. Now, step by step, when we are calculating the prefix sum, we will start adding that prefix sum in the hash map also. So when at index 0, we have calculated a prefix sum, it has came to -1. So is -1 present in the array? Is -1 present in the hash map? So answer is no. So -1 is not present in the hash map. We will add this -1 as a key in the hash map. And what will be the value? Value will be the index, current index. Value will be the current index, that is till where the sum of the elements are present. So this sum represents the sum of the elements till index 0. So this is why the index will be here. Okay, this is why the index will be here. Next we will go, we will see that some value is 0. Now some value is 0 till here. Some value is 0 till here. So we will check whether the 0 is present in the hash map or not. So yes, 0 is present in the hash map. Now 0 is present in the hash map, and 0 now we have again encountered. What does it means? It means that we have found a sub array. We have found the sub array within which the sum is 0 and it contains equal number of zeros and 1. So we will have a variable called count. Okay, sorry, length variable we will have. Initially it will be 0. Okay, initially it will be 0, and now we'll be calculating the length of the sub array. So length of the sub array, this is the j, and the value that we'll be getting from the hash map will be I. So we will simply do, to find the length of the sub array, that the which contains the sum 0, we will simply do j minus I. J is the index of this and I is the index of this. So index of this is 0 minus -1. So this has become 2. So out of 2 and length 0, but which one is maximum? So 2 is maximum. So we will be taking 2 here. Okay, for every step we will be repeating the same steps only. Okay, now let's move towards the next index. Next index in sum is 1. So till here the sum is 1. So 1 is not present in the hash map. We will add it in the hash map and we will update, we will add the index as 2. So till 2 the sum is 1. Next coming to sum 0. Okay, sum 0. Again till here the sum is 0, that for the first 4 elements. Now is sum 0 present in the hash map? So yes, it is present in the hash map, and -1 represents the index. So this is again the current index now becomes j minus the I that will be coming from hash map only. So j is 3 minus I is -1. So 3 and 4 is 4. So out of 2 and 4, which one is maximum? So 4 is the maximum. Okay, so this index is, this particular thing is done. Now we will move towards the next index. Okay, so next index, at next index the sum is -1. So is -1 already present? So yes, it is already present. So what will be the value of j? J minus I will be doing, -1 is already present. So j is the current index, that is 4, minus what is the index of I? Index of I is 0. Index of I is 0. So this is 0. 4 minus 0 is 4. So 4 and 4, out of 4 and 4, which one is maximum? 4 is the maximum. So after this iteration is over, inside this length variable, we will have the length of the largest subarray. Largest subarray with equal number of zeros and 1. So I hope now the approach is clear to you. I know many of you might have doubts. You can watch the approach again, or you can let's just move towards the coding part and the things will become more clear to you. Okay, so guys, for saving time, I've already written the code and I will be explaining you line by line what we are doing. So first of all, we are declared a hash map, and like this we are declaring in C++, and we have added one key and value to it by default that I've already told you that key will be 0, that is the prefix sum, and index will be -1 for initially, that is this is for the base case. Next is we are initializing a variable called prefix sum with 0 and length also 0. So prefix sum will contain the sum of the elements till the ith index after every iteration, and length will be containing that length of the maximum subarray, which will contain equal number of zeros and 1. Now what we'll do, we'll be iterating over the array. Okay, if the current element is 0 or 1, uh, okay, if it is 0, then we are adding -1 to the prefix sum. If it is 1, we are adding 1 to the prefix sum. Now, once we have got the prefix sum, now we will be checking that whether that prefix sum already exists in the hash map or not. Okay, like we have done it here. So if that prefix sum was already is already not present in the hash map, okay, if it is not present in the hash map, then what we are doing, we are simply adding that into the hash map with the current index. And if that prefix sum is currently present in the hash map, by this we check whether it is present in the hash map or not. Okay, so if it is already present in the hash map, then first of all we will be finding the j value. Okay, so j value is the current index. Okay, as I have told you, j minus I we were doing, so j was the current index. Like let's suppose if we were here, so j will be the current index and I will be the value of that prefix sum in the hash map. So I will be the value of that prefix sum in the hash map. So for calculating I will be the value of that prefix sum in the hash map. This is how we will find the value in the hash map. So we have our I also, we have our j also, that is the current index, and then we will simply do j minus I to find the length of the subarray, which contains equal number of zeros and 1. Now this length, once we are found, this length will be compared to the current length. Okay, so this length variable was, but it was containing the maximum length of this subarray containing equal number of 0 and 1. So now the current length that we have found out, it will be compared with the previous max length, and if that current length will be maximum, and out of the both of the maximum, the length variable will be updated. So we have discussed both the cases, whether the prefix sum is found in the hash map or if the prefix sum is not found in the hash map, then what we'll do. Once you have found the maximum length, we will be simply returning the length from this particular function. Okay, and in Accenture you do not have to manually take the input. The input will be taken care by them. You will just have to implement the function and return the required answer. So we are simply returning length from here. So let's just quickly run few test cases and let's see whether it is working fine or not. So 0 1 1 0 and 0. So this should give us 4 as the answer, as we have seen earlier. Okay, sorry, there is one syntax mistake. Okay, so now let's just run it. So it should give us 0. Oh, sorry, 4 as an answer. Okay, 4 is coming as an answer. So if we will take one more one, add it at the last, then it should give us 6 as an answer. So one more test case, let me just copy paste from here. Just a second, let me just copy paste from here and we will go. So this has given 6, and let me just copy paste this also. This should also give us 6 only. Okay, so in this input also the length of the maximum subarray is from this to this, so answer is 6. So it means the entire code is correct and every case it will be passing. So I hope now the approach and the question is clear to you and the code is also clear to you. Still, have you have any doubts, you can write in the comment section. And guys, do support us by hitting that like and subscribe button for this channel. Question here is, you are given a program to find count of magical numbers from 1 to n. Okay, a magical number is defined by the following criteria. So there are two criteria given, 1 and 2. So there will be a number n that will be given to you. So from 1 to n, you will have to find all the magical number. Now what is a magical number that is fulfilling these two criteria? Let's just read one by one. So first is replace 0 with 1 and 1 with 2 in the binary string. I know it's a bit confusing. I will try to explain you with the help of example, input and output. Don't worry. Next is calculate the sum of digits of the modified binary string. If sum is odd, it means it's a magical number. Okay, let's just see the input. So input will be n. Okay, so input is 5. So what question says that we have to find the magical number from 1 to n. N is 5. So from 1 to n, what will be the number? 1, 2, 3, 4, and 5. Okay, we will do one by one. First step. Okay, first let's consider this first number. First, let's consider this one. Replace 0 with 1 and 1 with 2 in the binary string. So what is a binary of 1? What is a binary of 1? So binary of 1 is 1 only. Okay, binary of 1 is 1 only. Now we have converted into this binary form. Now what it says, replace 0 with 1 and 1 with 2. So first we have to convert into binary form. Then we have to replace 1 with 2. So this 1 will be replaced with 2. Okay. Then this first step is done. Next is calculate the sum of the digits of modified binary string. If sum is odd, it means it's a magical number. So calculate the sum of digits of the modified binary string. So what is a modified binary string? So this is this modified binary string. So what will be the sum of modified binary string? It will be 2. It will be 2 only. So it is even. So this 2 is even. Okay. So once you have calculated the sum, if the sum is odd, it means it's magical number. So the sum is even here, so it is not a magical number. Okay. So I know again the things might not have been clear to you. Let's just move towards the next number. First step, what was it? First step was to convert it into the binary form. What is the binary form of 2? It is 1, 0. Next step is what? Replace 0 with 1, 1 with 2. So replace 1 with 2 and 0 with 1. So 2, 1 will become binary string. Next is what? Calculate the sum of these digits of the modified binary string. So calculate the sum of these digits. So 2 plus 1, it becomes 3. So 3 is odd. So yes, it is a magical string. Next example, let's move towards the next example. Let me just bifurcate it. Okay, next example is 3. Okay, first let's just convert it into the binary form. So it will be 1 and 1. This is the binary form of 3, normal binary form. Then we will apply the logic of magical number. Replace 0 with 1, 1 with 2. So 1 is replaced with 2. Again 1 is replaced with 2. This is the modified binary string 2, 2. Again the second step, calculate the sum of the digits of the modified binary string. So sum of the digits is 4. Sum of the digits is 4. Okay, what is it? It is an even number. So we know that if the sum is odd, then only it's a magical number. So till now only this second 2 was the magical number. 4 is also not a magical number. Moving ahead, what is 4? So again, let's convert it to the 4. What is the binary number? 100. This is the binary form of 4. So again, let's convert 100 to the required one. So 1 is replaced with 2, 0 with 1, again 1. Next, calculate the sum of the modified string. So the sum is 4. So it's an even. So it is not a binary number. It is not a binary number. Next is 5. Sorry, not a magical number. Next is 5. 101 is the binary form of 5. Again converting the modified one. So 1 is replaced with 2, 0 with 1, 1 with 2. Again we will add these all number. 2 plus 1 plus 2, it becomes 5. So 5 is odd. So yes, it is a magical number. So from 1 to 5, 1 to n, how many magical numbers are there? So total 2 magical numbers are there, 2 and 5. So what we have to return? We have to output the number of magical numbers. Okay, just 1 second. You are given a program, find the count of magical numbers from 1 to n. So how from 1 to n, how many magical numbers were there? Total 2. What were they? 2 and 5. So what should be the output? Output should be 2 only. So output is 2. That is that total 2 magical numbers from 1 to 5. I hope the question is clear to you. Now let's just quickly move towards the approach. The things will become more clear in the approach, and then we'll move towards the coding section. Okay, and again, before moving ahead, first thing I want you guys is to hit that like button, and second thing is that write in the comment section that what is your batch, what is the expected date for Accenture interview, what is your college. These three things you should mention. Again, I'm telling you, write your batch, that which batch you belong to, what is the name of your college, and when Accenture is coming to your campus for hiring. Okay, what is your expected date? And is it an on campus or an off campus? I think write in the comment section. Okay, so guys, for solving this question, what we will be doing, we will be using a bit masking approach. Okay, so it will be like good concept for you to understand. Like two operators are very necessary for this concept. One is this AND operator, and another one is this right shift operator. Now let's just first understand the AND operator. Okay, so if we have a bit binary string as 111, and we have another string as 0001, and we do AND operation, so what will be the output? So 1 and 1, we know it is 1. 1 and 0, it is 0. 1 and 0, it is 0. 1 and 0, it is 0. So doing this binary operation, or doing this AND operation with 1 gives us 1 only. Okay. So what can we conclude from here? Okay, let's just see one more example. So 1, 1, 1, 1, 0, 0, 0, 0. Okay. So 1 and 0, 0, 1 and 0, 0, 1 and 0, 0. So it gives us 0 because this bit was 0. So all these things 1 and 0 becomes 0. Now, if we like, if let's suppose we have a number called 15. Okay, what will be the binary form of 15? So 8 plus 4 plus 2 plus 1. This is the binary form of 15. Okay, now this is the least significant bit. Okay, this is the least significant bit. This is the least significant bit, and this is the most significant bit. Most significant bit. Okay, now if I want to, if let's suppose I have this binary number 1 1 1 and 1, I want to find that whether this bit is 1 or not. See, we know that 15 binary is 111, but in code how we will find that? Okay, currently which bit is there? So if I want to find this bit is 1, if I want to find that this bit is 1, what I will do, what I will do, I will just do an AND operation with 1. I will do just an AND operation with 1. Okay, so this will become 001. And if this bit was 1 and I have done an AND operation with 1, the result will be 1 only. If this bit was 0 and I have done an AND operation with 1, then what will be the answer? 0 0 0 0. So 0. So to find the least significant bit, to find out the least significant bit, whether it is a 0 or a 1, we do AND operation with 1. If the resultant is 0, it means that this bit was 0. If the resultant is 1, then it means that this bit is 1. Now I know that, see, you won't be understanding anything, but once I start to write the code, then many of these things will become relevant to you. Okay, we have understood the concept why we are doing AND operation. We have understood the concept of least significant bit and most significant bit. Now let's just understand the concept of right shift operator. Okay, if you are finding this information as useful, do hit the like button, and if you are finding this information as like it is of no use to you, just like dislike, you can dislike the video, but make sure that you are like seeing, if you have not understood this, you are seeing the code also, that logic that I will be writing. Okay, it is not a difficult logic to write, but it's like these things are you should understand these things. Okay, let me just remove all of this. Okay, just a second. Yeah, so now let's just understand the right shift operator. So currently the 15th binary was 111, so any binary you can take. Now if we do this binary right shift 1, if we do right shift 1, then what it will become? It will become 3 ones. So this least significant bit will be gone if we are doing right shift, because it will move towards the right. There is nothing at the right, so these 4 bits will become this. Now we have 111, and again we do right shift by 1. So what will happen? It will become 2 bits, because this again, this least significant bit will become again of no use. Then double 1, right shift by 1, again it will become 1, and again 1, right shift by 1, it will become 0. So this is the use of right shift operator, that once we do right shift operator, this number tends to reach to 0. Okay, these numbers tends to reach to 0. Okay, again I know the things will not be much clear. Once I start to write the code, the things will become more clear. Okay, just one more example of right shift operator I want to tell you. 1011, if we'll do right shift by 1, it will become 101. Again we'll do right shift by 1, it will become 10. So again we'll do right shift by 1, it will become 1. Again we'll do right shift by 1, it will become 0. So when we do multiple right shift operators by 1, then it tend to shift the bits it tends to make them to 0. Okay, now I have like and made you understand the two different concepts. One is AND operator, one is the right shift operator. Now let's just move towards the coding part, and then the things will become more clear to you. Okay, so let's start by writing the code. So first of all, we will be declaring n. See, I am writing the code in C++. You can write in Python also, Java also. Every language is suitable in Accenture. First word is n. Next is Cin of n. And why what is n? That 1 to n we have to find how many magical numbers are there. Now n. Okay, so n is, let's suppose 5 as we have taken as example. So what we'll do, we will loop from 1 for int I equivalent to 1, I less than equivalent to n, I plus plus. Okay, and for every number we will try to find that whether the current number is from 1 to n, whether the current number is a magical number or not. What are the steps for magical number? Okay, what were the steps for magical numbers? It was simple. Convert to binary. Okay, next step was make 0 bit to 1, 0 to 1, make 1 to 2. Okay, make 1 to 2. Next, what was we were doing? Add digits of resultant binary string, and check whether sum is odd or even. Okay, so these were the steps that we were following. So let's just do them one by one. First, convert to binary. Now see guys, there is one process that first we convert entire binary sorry first we convert entire this integer to binary, then we make 0 to 1, then we make 1 to 2, then again with that we convert to resultant binary string, and then again we do the sum. That is a bit tedious task. What we will do, for the current number, while I is greater than 0. Okay, while I is greater than 0, I is the current number. It can be any number from 1 to n. What we will do, see here, at every position we have to find, let's suppose we have 5 only. Okay, 5, and we are, this is the binary form. At every position, for every number, we have to find that what is this bit. What we'll do, we will try to find that what is the least significant bit. If it is 1, we will convert it to 2. If it is 0, we will convert it to 1, and we'll simply add it in a sum variable. Okay, sum variable. So for every number outside the while loop, what I am doing, I am taking a variable as sum, initializing it with 0. While I is greater than 0, we will try to find that what is our least significant bit. Okay, this is our task. We have to find that for this number, what is for this I, what is our least significant bit? Is it 1 or is it 0? So what we'll do, we will do AND operation of that I and 1. We will do AND operation like this. Okay, so if it was 1, then is this condition was successful. If it was 0, then we will move towards the else condition. If it was 1, what we need to do, that convert that 1 to 2 and then add it into the sum. So what we'll do, sum plus equivalent to 2. I hope this step is clear to you. First, we have checked whether the least significant bit is 1 or 0. If it is 1, we needed to convert that 1 to 2, and we have to, next step was to calculate the sum, check whether the sum is odd or even. Okay, so that we are simply straight away added that 2 to our sum. Else was if our least significant bit is 0. In that case, we have to add 1. Let's digest this step only, that we have I. Let's suppose our current I was 4. Let's suppose that our current I was 4. The binary equivalent of 4 is 1 0. Okay, then what we are doing, we are finding the least significant bit. We are doing step by step. We are finding the least significant bit. If it is 0, we are adding 1. If it is 1, we are adding 2. Next thing, see, now the role of this least significant bit is done. Now what we have to do, we have to go towards the next bit. For the next bit, we have to again find whether it is 0 or 1. So for that, what we do, least significant bit is done. We have to remove this least significant bit, and for removing this least significant bit, what we needed to do the right shift operation. So I is equal to I right shift by 1. So by this operation, this bit is removed now. Least significant bit is removed now. So this we have done right shift by 1. So this has now become 1. So this is not one integer, but this is 1 as a binary. So again this loop will run. So while I is greater than 0, so yes, I is greater than 0, it is 1. Again we'll check if this binary and 1, this binary and 1 is 1 or 0. So if it is 1, we are adding this sum plus equivalent to 2. Otherwise we are adding sum plus equivalent to 1. And again we are doing right shift by 1. So if this is again we are doing right shift by 1, then it will become 0. So once this will become 0, so the while loop for this particular I will tend to 0. And now we have our sum into this sum variable, and now we can check that if our sum is odd or even. If our sum is odd or even, so sum mod 2 double equivalent to 0, sorry, not equivalent to 0, then we are doing count plus plus. So magic numbers count plus plus. So let's just initialize this outside the main for loop. Int count equivalent to 0. I hope this entire logic is clear to you. If you still have doubt, just repeat it from the starting perspective in which I have explained the approach and code. The things will become very clear. It will be very simple. This while loop will be repeated for every number from 1 to n, and in the end we will check whether that sum is a negative or odd or even. If it is odd, then we are doing count plus plus, and in the end we are simply printing C out count. Okay, so if I give the input as, if I give the input as 5, our resultant should be 2. Okay, our resultant should be 2. So let's just see here. Okay, so sample input is 5 and our output is not coming. Okay, just a second, one mistake I think I have made. What is that? See, I am using this I variable in the loop also, and I am tending it this I into 0 also. So what we can do is int x is equivalent to I, and now I tend this, all the operations are done on x instead of I. So this is the, I think, the main problem that is happening. Let's just see if there is any other scope also. Let's just run it. See in, and we have done for int I plus plus. Okay, see, now the output is correct. So this was the minor mistake that you have to see, and this is the output that it is giving. So it is giving, it will give the correct output for all the cases that will be given to you in the exam. So I hope this entire question is clear to you, the approach is clear to you, the code part is clear to you. Okay, so even if you have any doubts, you can write in the comment section. Do join the do make sure that you're present on this channel, because more such videos I will be posting in this channel, and every day you will be learning a new concept. Okay, it will be very much beneficial for you for the Accenture exam.